Good morning. Oh, I'm sorry, y'all don't need a book. And you definitely don't need a pre-cal book.
You never know, we're reviewing. Do we get textbooks for calculus?
I don't know. We have textbooks that you can check out, but we really only use the book like 6 or 7 times a year. And there is a PDF of it online, so
Okay.
I don't know.
Are these both the same?
Sorry, these are not at all.
Oh. Same.
Yeah, if y'all picked up these handouts, I need these back.
Oh,
I'm sorry, those are not for y'all.
Okay.
Alright, I just noticed that those say recalculus.
Yeah.
It's my fault.
I was supposed to have that.
Mr. Townsend, I have a bone to pick really quick. So I
With
turned in my
me?
textbook, but you never turned it in.
What do you mean I never turned it in?
Like, I gave it to you, like one of the last days of school, and it's not in.
Well, what's the number? It's gonna be like, and that's
One of
that.
those.
Yeah, because I have
You
to
know,
check
I actually
them.
don't have the number with me, but I do at home.
Okay. Or on your email, maybe? How do you know it's missing?
I checked out a different calculus textbook yesterday,
Oh.
and she had to like override it or whatever.
But that could be for something else.
No, she said it's for this textbook.
Oh.
Oh. I'll look up overdue in my email.
I don't know, maybe it didn't scan when I went in. But yeah, if you just send me the number, you can even just email it to me. I'll find it over there.
Okay, wait, actually, I found it.
She's checking out books already?
Yeah. Well, like, she asked if any of us want a book instead of the online textbook.
Okay. I have to write it down. That doesn't have the book number, but
Oh.
I think I can actually look it up.
It has the barcode. That's all I know. But if you want the book number,
The book number's on there?
no. But the barcode is.
Oh, that doesn't help me.
Oh.
That's fine. I'll try to fix it today.
Okay. Thank you so much.
Well, that's my fault in the first place, so.
No, it's okay.
How are your new classes?
They're good. I'm scared for BC though. I feel like it's gonna be really
Don't y'all
hard.
review for like 6 weeks
Well,
or something?
Yeah, well, like, we're doing limits right now, and you know how much I love limits.
So, but you need it.
I know. It's actually not that bad. I remember most of it. What else? I have lit right now, and then I have physics, and Spanish before.
Physics is gonna be tough.
I'm really scared for physics. I'm hoping calculus will help me.
A little bit, but
Yeah. We'll see.
it's
How's
gonna
your-
be like calculus and chemistry again.
I know. How's your classes? Do you like
They're
them?
good. Yeah.
Do you like them?
I like calculus because I know a lot of these students have done it last year.
Pick out?
Yeah, so that helps. I don't know. Classes are just really big this year. This one has 30.
I know. My lit class has 30 people, and it's crazy.
Yeah.
I hate it. I don't like that many. packed. But
Well, and then for my pre-cal classes that are 30, the more students in here, the
Yeah.
less they'll talk because they're like scared of how many people there are. So
no, they need to talk.
yeah, it takes a while to kind of break the ice with
Well, we
pre-cal.
talk too much, you thought. So be thankful they're not to that point.
Yeah, that was y'all's one downfall.
Yeah, it's okay though. I passed the exam, so it doesn't matter. And I'm gonna get a 5 this year. You just wait.
I'm sure you can.
I'm gonna actually study, and then I will. Okay, I'll let you do. Oh my god, let me look at the memes.
Huh?
We do new memes every year. I need to reuse them. Don't
I
forget,
saw that from last year.
don't forget to use my meme.
Buenos dias.
Buenos dias.
We're in Spanish together, and our teacher only talks in Spanish. It's a real struggle.
I've been through there before.
Okay, I have to go to lit.
I forgot my ID today, so I texted my mom if she could bring it to me.
Okay.
So she might come during this period.
Okay.
I don't like
They'll call. Or they should.
Thank you.
Man. How are you gonna do calculus? You can't even figure out a 3-hole punch.
Dude, I don't know. This one's hard.
I don't see Cooper. Ashland. Oliver. Alberto. All right, we're gonna start class today with our quick little quiz, 5 questions. So I do need you to put your stuff off your desk for that, please. No calculator. And please just go ahead and start as you get it. Again, go ahead and start as you get it. I'm going to ask that you guys turn in 2 things, though, when you finish with this. Obviously, this is going to be one of them, so make sure your name is on it. But also, last class, I gave you the Get to Know You page for you to give a little bit of information about yourself. So when you finish this quiz, find the Get to Know You page in your binder, and then turn it in with this quiz. And you can turn those in up here in this metal basket. So you're welcome to take a couple minutes. You don't have to rush through these questions, but it is limited time because there's not that much to it, and most of these are either you know them or you don't. So. Thank you. Separate those two. Give me this from last class too. As you guys finish that up, there is a calculator question or two we need to ask you, and so there's a survey link on the agenda. So once I have your quiz, and you're good to know you. You missed it. We're done with it. So you need to get here on time. Moving on. Wait. Hold on, that doesn't look right. You use that link? That's up on the board?
I think so. Maybe not.
Okay. So there was one yesterday that you might need to refresh the page if that's where you got it from. Because, yeah. That's for Miss Cross's class, so that's why there's some confusion. last call. Any other quizzes? What?
I put words like the get to know you thing and
That's fine. I'll find them. I'll sort through them. Okay. All right. So if y'all would please fill out that survey. It basically just asks if you have your own calculator, if you plan on using our calculator. I think the plan is to try to get you a calculator to check out if you want one at home, if you don't have access to one. But I'm not in charge of that, so I don't really know. But I need you to do that today so that that information can go to the person in charge. Basket. Basket. Give you just one more minute to finish up the survey before we move on. I guess technically if one more minute's not going to be enough, you can do it, but you need to do it before the end of advisory today. And of course you may forget it, so if you don't, just do it now. All right, so while you guys finish that up, I'm going to talk about what the plan is for today. We got two topics we're going to look at. We are going to evaluate some more limits. So what we did last class, except last class everything was on a graph. And to me, that's one of the easier things we do. So the trade-off is we don't spend much time on it. So one or two of those questions may be on our first test. You'll probably see one or two of those on the review, but typically we just don't keep talking about limits from a graph. So if that's something you're struggling with, you know, normally you can come in during advisory or whatever, but you guys need to get that caught up as soon as possible. But now we're going to do it from just the function. So assuming we don't know what the graph looks like, we should still be able to evaluate those. And those can be very easy, even easier than the graph, to much harder than the graph. Much bigger range there. And then we need to talk about one of our three big calculus theorems called the intermediate value theorem, which is a pretty basic theorem about what it says, but you need to know it really well. And so then I'll have you do a little bit of practice on that, and then that will be our class period today. Okay, so when it comes to evaluating limits analytically, that means you have a function. So notice this question 1, it doesn't say f of x or g of x or h of x. It's not telling you which graph to go and refer to. It's actually just putting the function right here. So the main thing that we do in these problems, by far the most important part, whether it's an easy question or a hard question, is you have to know that you're supposed to start with direct substitution, and sometimes that's enough. And what I mean by direct substitution is you're just going to plug this in, and if you get a real number, you can assume that that is your answer. Plug it in, you get a real number, there's your answer, move on. So that happens sometimes. Of course, we're not going to focus on these because these just work out nicely. But what we're really doing here, I like to start off with x squared because you guys know what x squared looks like. We're saying as x approaches 3 from the left and the right, it's approaching a y value of 9. And that makes sense, right? That's what we did last time. It's just that we don't always know what this function looks like, so we can't count on always being able to look at the graph to do that. All right, question 2. This one's also not a problem. You do direct substitution. You get 4 divided by 0. And what happens when you take a number like 4 and try to divide it by 0? Okay, that's undefined, which makes the limit question have an answer of does not exist. You still can't divide by 0. Yeah. You'll be there every day. Okay, so those two are pretty straightforward. We plug them in, we get our answer. Can't divide by 0. Now, the very first big problem in calculus is we have to now deal with a question like number 3. If we do direct substitution here, our numerator goes to 0 and our denominator goes to 0. And 0 over 0 is one form of what's called the indeterminate form. So this one breaks some of the rules that you've learned in past math classes. Because at some point you should have learned if you have 0 divided by any other number, it's always going to be, well, we just saw up here, if you have some other number divided by 0, it's undefined. But 0 over 0 could be 0, it could be undefined, or it could be anything else. So I'm going to highlight this because this is the problem. That's what we are trying to address on this worksheet. Now, not every question on the next pages are going to be these type, but they are kind of sprinkled in here. So when you get 0 over 0, after we do derivatives, I can show you an alternative way that some students like, but we are not at that point in the year. So what we have to do is we have to rewrite the question, and we have to think of a creative algebraic way to make this look different. So not much I can do with x minus 4, but what can I do with x squared minus 16? Okay, so we can factor it. And factoring is the most common way to deal with 0 over 0. In fact, I can bet money right now that when you get to your AP test at the end of the year, one question is going to be just like this. You get 0 over 0 from direct substitution, so you have to factor it. Why is factoring it help? Right. Something should cancel, and when you have 0 over 0, you need this to happen. Until something cancels, direct substitution is not going to work. So I tried direct substitution. Unfortunately, it was 0 over 0. I thought of some creative way to rewrite it algebraically, got something to cancel. You still finish with direct substitution. You plug 4 into what's left over. If you still get 0 over 0, you got to do more work. If you get a real number, just like question 1, you can stop. Now, if it was always a factoring question, these wouldn't be so difficult. But really, basically, any type of algebra to rewrite this is fair game. Factoring is the most common one, though. I would be very, very surprised if we didn't put one or more of those on your first test. So, from that page, if you know what the graphs looks like, and you can visualize it like it's just x squared, then great, go for it. But otherwise, you need to reduce it to this. Direct substitution, hope you get a number. If you get 0 over 0, you got to rewrite this. And as we go through this assignment today, this doesn't provide a lot of practice of all the different types, but you need to start making a list. Right now, the only thing on your list is try factoring. If something factors, do it. If something cancels, cancel it. And after something cancels, try direct substitution again. If you end up with a number, you can assume that is your answer. So what I'm really doing here, even though that seems like a lot more work than what we did last time, it's a little bit impressive for what I'm figuring out. I have no idea what this graph looks like without spending a bunch of time on it, without a calculator. But I can tell you, as x gets closer to 5 from the left and the right, I know the graph is approaching a y value of 10. So with just a moment of work, I do now know something about the graph at least. All right, so we've got factoring. So the next page is a flowchart, and I did not make this, but I think it just kind of visualizes what I tried to say in those last few questions, and you have to structure it the same way in your head. You have to always start off with direct substitution. A couple of things can happen. You can either get a number, and that can be your answer. You can get a number over 0, and you can say it does not exist, or you can get 0 over 0. The indeterminate form. If you get 0 over 0, you have to do more work. It could be that you have to factor it, but it can be other algebra tricks like conjugates or trig identities. Anything and everything that you've ever learned is fair game. But you should rewrite it, get something to cancel, and then once something cancels, This flow chart tries to show you that it goes all the way back up here and you finish with direct substitution. So it's just a visual of what I tried to structure in those questions on the front. So nothing you need to do on this, but if it helps you organize that, then make sure you look that over. Okay, so on to the practice here. The practice is really a couple of those question types, not a ton. Really just kind of like one of each of the main ones. But then also one question with table and a handful of questions with piecewise functions. Not because these are really that much more difficult, but you guys do struggle sometimes with piecewise functions, at least at the beginning of the year. So let's look at a couple of these together, and then I'll give you a minute to try a few and see how it goes. So all of this goes with question 1. And it wants to know what's a reasonable limit. And this is exactly what we did last class, except you had a graph drawn for you instead of a table. But what's a reasonable limit for x approaches -2 of g of x? So what did we say last class about how does the limit, what has to be true for a limit to exist?
That's determined from the on the right and the left.
Okay, what is this approaching from the left?
8.
Good. Looks like as x gets closer to -2, the y value is getting closer to 8. So this would be from the left. What about from the right? If the limit from the left approaches 8, the limit from the right approaches 8, it's reasonable to assume that that is approaching 8 now. Now again, it's just a table form instead of a graph like we did last class, but same thought process. Okay, let's look at maybe just 2 to 3 of these piecewise functions. All right, this one, number 2, wants us to look at this piecewise function and figure out the limit as x approaches -5. So with the piecewise function, you've got to think about which piece of the piecewise function you need. Sometimes it's both. And sometimes it's just going to be one of them. Oliver, you don't need your calculator right now. So if I care about as x approaches -5, which one of these two should it be going to? Right, the bottom cares nothing about when x is -5. Got to think about this restriction. But right here, the top works when x is between -8 and 0. So this top is not just for the left, it's also for the right. It's for both of these. So if you do direct substitution and plug this in, it looks like this. And this is why we try to push you into studying the unit circle before class if you need it. At -5 pi, the y value, which would be sine, would be 0. If you feel like you did not do well with those unit circle questions today, don't be dismissive. You need to know the unit circle. It shows up a lot. Okay, whereas a question like number 3, I know some of this didn't print off great. This was supposed to be from the left only, but we're going to make it just as x approaches 3, both. So, what we talked about last class, and at the top of this page with the graph, is that for a limit to exist, it has to approach the same thing on the left and the right. So if I want to know from the left, which one of these two should it get plugged into? Okay, why the top one?
Because it's less than 3.
Right, if it's coming from the left, that's when x is slightly smaller than 3. So from the left, I need to plug it into the top, and we would get 8. But I also need to know from the right. This didn't apply to the last one. This is where you can't oversimplify it and just say, I'm going to plug it into both every time. You would plug it into the bottom one for the right, because this is when x is bigger than 3. And if you're coming from the right, x is going to be slightly bigger than 3. So you plug it in here, you get, and from the left, if it approaches 8, but from the right it approaches 7, then the answer to this question would be
Does not exist.
good, because they have to be the same. They have to approach the same number on the left and the right. So if the question said from the left only, your answer would be 8. If it said from the right only, it would be 7. But since we changed it to say both because it didn't print off great for you, these have to be the same for that to be your answer. If they're not the same, say does not exist. Okay, I'd like you to do one real quick as guided practice before I give you a couple minutes to try some. So look at number 4. And did this print off? Again, I just don't know what printed off. Does this say as x approaches 4 from the right? Or can you see from the right? Okay.
Yeah, -4.
Just change it to as x approaches -4 only, not right or left. I always need to print this worksheet a little bit darker and I just forget. Start of the year, so think about what you need to do. Don't just mindlessly plug it into the top because that's what we did on the first one, or plug it into both because that's what we did on the last one. You've got to think about that restriction on the right to make sense out of which one it needs to go into. Just depends. Okay, I believe, without working it out, I believe it does not exist. Is that what you got? Okay. If you got that and you were pretty confident in that answer, then feel free to tune me out here and just go ahead and keep on going. But since we said as x approaches -4, I know I need to worry about the left and the right. I need to see if they're the same. So the left is when x is a little bit less than -4, so that would get plugged into the top, and you would end up with -1/3. And then the right, x is going to be slightly bigger than -1/4, or -4, sorry, not 1/4. So it gets plugged into the bottom, which is 2 to the -4, or 1/2 to the +4, which is 1/16. But these are not the same, so that's why the answer should be does not exist, the final answer. If you don't phrase every single question like that in your head, what's it from the left, what's it from the right, are they the same, then you're going to make a lot more careless mistakes than are necessary. Okay, what I'd like you to do, and I know there's a few of these on this page we're still going to need to talk about together. Some of them are like the ones on the front page, but a little bit more difficult, but there's also a couple piecewise functions. So go ahead and try a few more of the questions and give me a second to grade a few of our quizzes today. And then we'll join back together, make sure we're all on the same page with these problems, and then we can move on.
Do you want all of us, do you want us to do them like that they're coming from both sides? Because we can't really see if there's other numbers.
I think the rest are coming from both sides anyway,
Okay.
so.
Thank you.
And if you get to one that looks a little bit harder, do the part of it that you think you can, and then if you get stuck, just move on. Bless you. Okay, let's look at a couple together, and then I'll give you a little bit more time to try the rest. All right, question 5. I think it does not exist. Is that what y'all got for number 5? Okay, so as x approaches -3, you've got to test the left limit, which would be plugging into the top, which is 2, square root of 4. And then the right limit, you have to plug into the bottom one, because that's where x is greater than. So it gets plugged into the bottom, and you end up with 4. So the left limit is 2. The right limit is 4. Those are not the same, which is why the final answer on this one should be does not exist. Questions on that one? Okay, and then you should have had enough time to at least try 6. And if you did pre-calculus last year, you're probably more likely to think about how to start this. But this isn't just a piecewise function, so like we did on the front page, you need to start with direct substitution, hope you get an answer, but if you get 0 over 0 like we do in this question, you've got to figure out a way to creatively make this look different without changing the size. So the only method that may be on your radar right now was factoring. This does not factor. The numerator doesn't factor, the denominator doesn't factor. So you have to try a different algebra trick. So, did anyone have a guess about what algebra trick that might be?
Conjugate.
Very good. The conjugate, do you think it should be the conjugate of the numerator or the denominator? Okay. What makes y'all think it's the denominator? You're correct, but good. The square root is kind of a hint about conjugates. So, we want to multiply by the conjugate of the denominator. I'll remind you, conjugate just means change the middle sign only. You have to multiply the top and the bottom by the same thing, otherwise you're not multiplying by 1, you're changing the size. And then if we multiply these fractions together, our numerators become an x minus 2 times that conjugate. But our denominator should simplify quite a bit, because anytime you multiply something by its conjugate, most of it's going to cancel out nicely. 2 terms times 2 terms is going to be FOIL. Here's the first part of FOIL, the outer part of FOIL, the inner part of FOIL, and then the last part of FOIL. Square root of 3x minus 5 times square root of 3x minus 5 is going to be 3x minus 5. Now, if you did do the conjugates and you got close to this far, or if you even made it past this far, here's the most common mistake that you guys may have. A negative times a positive is negative. It's not the 3x that's negative, it's the whole 3x minus 5. You need to put parentheses there or distribute the negative right away. So again, negative square root of 3x minus 5 times positive square root of 3x minus 5, it ends up being negative 3x minus 5. The whole thing 3x minus 5. Now, the reason why we like conjugates, and it's a nice little trick, is the outer and inner part of FOIL always cancel. So I'm not doing anything with the numerator yet, because that looks like a mess. But the denominator, I can combine some like terms. I've got a negative 3x. And this one with this plus 5 makes plus 6. Now, I've done lots of work, but how do I know that I shouldn't do direct substitution yet? Okay, but not every question is going to have factoring, so let's try to not go that route. Something needs to happen before we do direct substitution. Okay, not this question specifically, not factoring. Something has to happen before I know direct substitution works. Something has to cancel. So in this case, you guys are just one step ahead. You could factor your denominator, because now something cancels. That's the big thing though. You need these hard questions, you need to know what you're aiming for. What you're aiming for is for something to cancel out. And now that something cancels out, you should be basically done. Plug it into the mess that's left behind. Looks like we get a 2 on top. Nothing to plug in on the bottom, negative 3. So the answer to that question is negative 2/3. So, in a perfect world, I would assign 50 of these for y'all to practice so that you just had the drill and kill. But realistically, there's just more question types. So this is the only type of this we're going to look at today. But our list, mental list that we're making, when we get 0 over 0, try factoring first. But if it doesn't factor, you might have to try the conjugate trick. And then we've got an example. So. Okay, anything I want to ask about 6 while it's up there? Okay. Let me give you a couple more minutes then, because I want you to try a few more. So, same thing as before. You get stuck on one, just do what you can, and then wait till we talk about it as a group.
Okay, let's say 2 more minutes here. I realize a couple of them take longer and they're kind of hard to finish if it doesn't jump out at you, but that's okay. Okay, let's try to fill in the gaps here on the ones that you got stuck on. So number 7, it's a piecewise function. Did you need to plug this one into the top or the bottom? Okay, both, because of how this is set up. This would be from the left, this would be from the right, and it looks like you get -1 both directions. So number 7 should be -1. Any questions there? Okay. Number 8, you try direct substitution. Without a calculator, some of these numbers get a little bit bigger, but it looks like you should get 0 over 0. Hello? Yes. Okay. Thank you. It's your ID, but wait till we find a stopping place, okay? Okay, so you plug it in, you hope that you get a number because then you're done, but unfortunately this one goes to 0 over 0. So mentally, even though we're not practicing a lot of each of these questions today, I will certainly put more of these question types on our test review, but you have either factoring or conjugates, and I told you factoring is the most common one. So you should have factored the numerator, GCF, factored the denominator, difference of two squares, something cancels like it has to, and then you plug it into what's left over. You get 16 over 8, so in the end you get an answer of 2. We good with that one too? Okay. Now again, I mean, factoring, if you feel like you're weak at factoring or make a lot of factoring mistakes, you need to take it upon yourself to start practicing that some, because we do use it quite a bit. But short of that, it's fine to think that some of these questions are hard, especially the last couple ones, but what's not okay from a calculus standpoint is you should take less than 2 seconds to know that you start with direct substitution. You should take less than 2 seconds to know that if it's 0 over 0, you have to make this look different. It's fine if you have to really think about, how do I factor this? How do I multiply by the conjugate? It's got 5 steps, it takes me a while, but the structure of what your process needs to be, you need to have down real well. Alright, so number 9, you try direct substitution. You get -11. That's a real number, so you're done. It's not every single question is going to be 0 over 0 and be a pain. Sometimes you get a real number and it's nice and quick. Okay, then you got the question 10. You try direct substitution. The numerator all goes to 0. The denominator all goes to 0. So this one's going to be a little bit more work. So mentally, our checklist we're making in our head today is factoring has helped on multiple questions, but nothing factors. The only other method we've looked at together this morning is conjugates. Conjugates are also not going to help here. Conjugates typically only help with square roots. So, does anyone remember what it's called when you have these smaller fractions within a bigger fraction? One more time. Close. Complex. Complex fractions. So really the trick to this one, it's not factoring, it's not conjugates, it's a different algebra skill. You have to know how to make this complex fraction look nicer. So the thought process behind complex fractions is you want to get rid of these smaller fractions. I would love to multiply this by 4 because it makes that go away. But mathematically that's not okay unless you multiply everything by 4. I would really like to multiply this one by x squared because it makes those cancel. But mathematically, we're changing the question unless we multiply everything by x squared. Basically, what I'm doing is multiplying the top and the bottom of this fraction by 4x squared and distributing. Because I'm multiplying the top and the bottom of my fraction by the same thing, I'm really just multiplying by 1. Okay, and then the dust settles. You've got 3 times 4 minus 3 times x squared all over a 4, an x squared, and an x minus 2. You also kind of need to think of this guy as a fraction too. It's just that he didn't have anything that needs to be canceled out. So, you were supposed to know how to deal with complex fractions. I know realistically y'all don't see complex fractions a lot, and you don't need them a ton for calculus, but they do show up sometimes with limits like this. So you need to know this first step. This is the type of thing you need to look back over. Now, back to the other, now it looks like a question that we've been doing. The complex fraction part, the unique part of this question is now over. I still know not to do direct substitution because nothing's canceled. But I do know I could factor this. I could maybe pull out like a -3, or I can try to pull out a -3, see if it helps. Do you see that this factors more? It probably helps if we switch the order of these. Make it x squared minus 4 instead. Same thing. Because this is the difference of two squares. And again, you get a little bit of a hint because you know something's supposed to cancel. In this case, it ends up being the x minus 2's. And now that something has canceled, direct substitution should work. Now, it gets kind of messy, so you do have to know what you've got left over here. But it looks like we got -12 on the top, 16 on the bottom, and that reduces to -3/4. So once again, in a perfect world, if y'all had no other classes and no other outside stuff, I would probably need to assign 20 of these for you to do just for the repetition. But for now, you guys need to know that if factoring does, if it's 0 over 0, it's not factoring, it's not conjugate, it could be a complex fraction, and know how to get from here to here. Know how to make it not be a complex fraction so that you give yourself a chance. All right, that one's a little bit more involved. So is there anything y'all want to ask about that one before we look at the last two? Okay, let's go to the last one just because it's quite a bit easier. Did y'all have enough time to get to this one? Okay, so direct substitution, you get 4 over 0, which ends up being, does not exist. You can't divide by 0. Only 0 over 0 should you be jumping through all of these hoops and doing all the extra steps. Okay, and then one more. Just show you one more question type that comes up with this. But you try direct substitution on 11, you end up with 0 over 0. You have to know the unit circle to even know that that happens. So please continue studying that if you need to. I know that factoring has helped most of the time, and it looks like I could factor the denominator. It's got a GCF at least, but the problem is nothing's canceled. So factoring alone is not enough. This is not a conjugate question, unfortunately. This is not a complex fraction question. So all of the other tricks and tools that we've tried on other questions just don't apply to this one. This is something different. So what could we try to make it look different? Okay, I hear y'all, but my brain's not registering. One more time. Okay, specifically, what is this one equal to? Very good. So those of you in pre-cal are going to be very familiar with this. If you don't have that one memorized, you absolutely must memorize it soon. This is the one that shows up a lot in calculus. Sine squared of an angle plus cosine squared of an angle always equals 1. So cosine squared is equal to 1 minus sine squared. Now, as you see, this doesn't come up every single question. This is the only one where we had to plug in a trig identity. But if you don't know to plug in that trig identity, you don't know how to rewrite that. If you don't know how to write that, you're probably never going to get it to factor. It's just a difference of two squares. And if you don't do that, then you're never going to get anything to cancel. Spend all day on that question, but if you don't know that trig identity and you don't see the factor of the difference of two squares, you may never finish it. But something cancels, plug it in. You still need to know sine of pi over 2. So it looks like we should end up with 3. So direct substitution, hope you get a number. If you don't, if you get 0 over 0, try factoring, try conjugates, try complex fractions, try trig identities. There's a short list of things that you need to consider. All right, Julie, you have something? Okay. All right, but that's a lot of information. But again, we'll practice this a little bit more on review day. It's fine to think this is tough. It's fine to need a little bit more time than I gave you. But what you absolutely is non-negotiable. You have to know, start with direct substitution, 0 over 0. You need to know what you're trying to achieve. Now, whether you achieve it or not is a whole nother thing. But if you don't know the process and that you finish with direct substitution, then you're going to be in trouble. So. All right, does anybody else have any other questions on this one before we put it aside? Feel free, of course, to make some mental notes here. If you need an explanation in words, you know, if you need to make some kind of connection about how this became this, of course you should update your page so that when you look back at this, whether it's before our first test or before the AP test, you have something there that will explain it to you. Okay, then let's move on to the other handouts y'all have today. So we've got three big theorems in calculus: mean value theorem, extreme value theorem. We get to those later in the year, but early in the year we do IVT, which is intermediate value theorem. And honestly, this theorem is kind of confuses students sometimes because it's almost so common sense that it's hard to understand what it's trying to say. But when you hear the word intermediate, what does that mean to you? Do what? Yeah, something in the middle. So that gives you a hint about what we're doing. We're talking about values in the middle. So all IVT says is that if it's a continuous function, which we'll get into more details about later, but a continuous function doesn't have any breaks. There's no like asymptote, no holes, just a nice smooth function. If it's continuous from some x values a to b, your function has to take on all of the y values between f of a and f of b. So I've got three examples here. Let's say that we need to connect a and b and make them continuous. So I don't know, maybe it looks like that. Because this is continuous from a to b are the generic x values. All IVT says is that it has to hit all of these y values. Do you see how it hits all of these y values at least once? Now, if your graph is more interesting, it may hit these y values more than one time, but IVT guarantees that it happens at least once. Or it can be something real basic. It still guarantees that it has to hit all of these y values in between f of a and f of b. Intermediate, in between. It's guaranteeing the y values in between them. Okay, so let me elaborate on that just with a couple numbers, just because I think that may help. And then I'll show you some of the question types. So pretend like this is at, I don't know, 1, 2, and this is at 8, 10. These 2 points. So it's not generic A and B. If, we don't know what this looks like, but if it's connected and it's continuous, I can tell you between 1 and 8, that's when, that it has to hit every y value from 2 to 10 at least once. Maybe once, maybe more than once, but it has to hit every y value between 2 and 10. So, some of the questions that you guys will see at some point will be something like this. First off, figure out if IVT applies between 1 and 2 of this function. So we don't know what this function looks like. I'm not going to graph it in our calculator, but we can figure out that the y value it starts at is the y value when x is 1. which is about 33/16. And we know the y value that it ends at is f of 2. And this question is asking you, does IVT guarantee that it has at least one 0? Well, what does it mean to be a 0?
It's the X value.
Okay, so the x value when y equals 0. So if we know this guy starts off at this y value, and this guy is continuous because polynomial functions are always continuous. If he starts off at this y value and ends up at this y value, are we sure that y was 0 at some point in there? Yeah, it's going from positive to negative. It has to hit every y value in between. So we are 100% sure that this is going to happen. Now, on our notes, sometimes you need to practice this as well. You also need to... Oh, well, we can do that on the next questions. That's fine. Sometimes you need to figure out where it happens as well, not just that it does happen. Okay, so again, different questions, same process here. Between 0 and 5, we want to verify that IVT is going to apply to this. Continuous, because it's a polynomial. I can figure out its starting y value and its ending y value. And because it's continuous, I know what it's saying is it has to hit every y value between -1 and 29. So does that mean that it has to hit a y value of 11?
Yes.
Yes. If it's hitting every y value from -1 to 29, it's certainly hitting a y value of 11. Now, this one, they want us to practice figuring out where it happens. Well, if I want to know when this function has a y value of 11, you could just set it equal to 11, and then it should look like stuff that you did in Algebra 2 a lot. Quadratics, you want on one side set equal to 0. Most of the time you can solve with factoring. There are a few times this year you'll have to pull out quadratic formula, but not too often. Looks like there's 2 times that this function has a y value of 11. When x is -4 and when x is 3. However, I really only care about one of these for this problem. Which one of these do you think we should keep? Okay, keep 3. What's wrong with the other one? Close, not in the domain. So even though it's true here, we were just told to worry about 0 to 5 in this question, so we don't really care about what's happening at -4. So again, you kind of just glance at this as a whole. The right side is stuff you've been doing for years. The left side is just knowing that it was going to happen and understanding what IVT says. So one last time, and then I've got a couple of these for you to practice online. So they want us to figure out, does this function ever have a y value of 0 between 0 and 3? Well, it's a polynomial function, so I know it's continuous. I know the graph's not jumping around. I can figure out the y value that it starts off with and the y value that it ends by plugging these in. And again, IVT is not complicated theory, but you have to understand what it's telling you. Because this graph's not jumping around all over the place, if he starts off at a y value of 8 and ends at a y value of -1, I can promise you it's going to hit all of the y values between those at least once. 0's between those, so I know it will have a y value of 0 somewhere between 0 and 3. Now, to figure out where it happens, if you need to do that, sometimes you do, sometimes you don't. Plug in 0 for y and solve to see where it happens. quadratic. Luckily it factors. Looks like this function hits the x-axis 2 different places. However, we really only care about this one for this problem. There's nothing wrong with 4, it's just that we were told to only worry about 0 to 3, and 4 is outside of that, even though 4 is true too. 4 was just not guaranteed by IBT because we didn't check that. We checked between 0 and 3. Okay. Anything that jumps out at you immediately on these? Okay. Then, I don't think you're going to need a lot of scratch work, but I do need you to have your own piece of paper here. Number it is number 8 in your binder. And I've got 2 Khan Academy assignments assigned to you. So, get out your scratch paper. Any scratch work you need to do, put it on there. I don't often need this because it grades it on Khan Academy. But then either on your phone or on your Chromebook, go to khanacademy.com, sign in with your school email, and you should have 2 assignments. One of them is about trying to figure out when to use IBT. And one of them is actually trying to practice using IBT. So, Khan Academy, I have you guys do this one quite a bit first semester because Khan Academy does a good job of giving you a lot of practice. I do want you to stick with these 2 until you get 100 on each one. There are only 4 questions, so if you get 4 in a row right, you get 100 on that one. You get 4 in a row right on the other one, you get 100 on that one, then you're done. But if you're making mistakes, there's something about it that's just not real clear and you need to ask. If you miss a question, you can click to get help and it will show you maybe where you went off. But the other thing I like about Khan Academy is that you're welcome to try it as many times as you want. So somebody who totally understands what's going on and it totally clicked with them already, they only have to do 8 multiple choice questions and they're finished. But if you're struggling and you need more practice and you got to do them several times before you get 100, then you're getting more practice. So.
Where can I go to that survey?
Where can you go to it?
Yeah, how do I get to it?
Well, you can type that in, or if you go to our class website that you bookmarked last time. You can go to the calculus part. It'd be in the slide should be in the top right. I think if you click somewhere in there, you can make it like full screen, and then you just click the link.
Thank you.
Yep. All right, and you'll have about 23 minutes. So it's certainly conceivable you could get 100 on both of these while you're in class. That happened yesterday with a lot of people. But if you don't, then that's what I need you to do for homework. I need you to stick with these 2 until you can get 4 in a row correct of each type. And also, I don't care which one you do first. Whichever one sounds easier, if you want to knock it out, then go for it. But when you miss a question, I highly suggest that you don't just keep on going. Click the get help, see what it was that you didn't consider or did wrong, and then that way you're going to learn from your mistakes and you're going to get to 100. Go to KhanAcademy.com. Honest, I don't think y'all need scratch paper too much on many of these questions. I don't think they take many steps. But I still like you to have the place in your binder because if you make some notes to yourself, if you just keep making the same mistake and then you learn from that mistake, it's really good for you to write it in words on paper that gets filed in your binder. Because between now and May, a lot of stuff's going to happen, and it would be good for you to have that quick summary of whatever hurdle it was that you were overcoming. So.
also welcome to approach this any way you want to, but if I was you, I wouldn't put too much thought into any one of these questions. I would just give it the first few a shot. I wouldn't like hold my breath and expect myself to get the first 4 correct without making a mistake. And then once I feel a little more confident, maybe I'd slow down and aim for 100, but that's up to you. As long as you end up with 100 on both of them. And then this technically is due, I think it says in Khan Academy, but before we start next class, I believe. So this is an A week. So as long as you get 100% on both of these before Tuesday of next week, you'll get full homework points. Whether you do it 1 try or 50 tries, you still get the same homework points. Now, if you don't do it today in class or in advisory, you may not remember it, but well, if you really want a visual, you could plot those 4 points and then just kind of roughly connect them. But I don't think you have to. So could y be 0 between 1 and 3? What y value is right? Because for all you know, it's always negative. It could go to 0, but you don't know it's 0. So definitely. But between 3 and 4, it has to go. And between 4 and 6, it has to be. Right. If it starts off at 2 and ends in -5, it has to be at 0 somewhere.
What am I supposed to write down?
I don't know. I do the grades from Khan Academy. It lets me see, and I also like it because I can see if everyone's missing the same question. But this is good if like if you do need scratch paper, or if there's a common error that you're making and you figure it out, you should put it in your binder and you can find it later. Now with these questions, I'd be happy to help you, but I'm not going to do the questions for you because I want you to get enough in a row correct. But if you miss one and you're not sure, you click the get help and you're still not sure what you should have done, don't know how to start the question, then please let me know. I will try to give you some help. Doesn't have Khan Academy.
I just
I have these mini quizzes graded from this morning. Again, the main thing is just trying to point out to you, if you miss all the unit circle questions, you still need to review those. Or log properties, or both. Sorry?
What do we do after the Khan Academy quizzes?
Once you get 100 on both, you're done. So that's the last thing I got for y'all. So if you get 100 on both while you're in class, you're welcome to either look back at that handout before this, which I think some of those questions are a little bit harder. And if you really feel good with that too, I guess you've got 2 minutes. You can work on something from another class. But just for some perspective, this mini quiz today is only 5 points, and Khan Academy will be 8 points, 4 points each, so. So if you're not happy with your quiz grades, won't be a big deal, but you do need to go pick up those skills.
I don't have anything else to look at. So look back at those two.
I don't think I took that mini quiz.
Yeah, you came in late, so you missed it.
Oh, okay. Can I take it?
No, you just missed it. You gotta be here on time for this. Okay, I am done passing those back, so if you have a question, please raise your hand and I'll come help. Y'all still have about 9 minutes here, so still time to finish them up, potentially.